one request. Two services. Same customer, same transaction, same wording. The first answers with a label and a number. The second answers with a paragraph. Send the identical request again. The first repeats itself word for word. The second writes something new. Both are called AI. Only one can be tested the way you test everything else you ship. By the end, you will know which shape a feature needs before anyone picks a model. Look at what came back from each one. The first reply is a fixed shape. It has a field called fraud set to true. It has a field called score set to 0.94. Same two fields every single time. The second reply is a sentence. It could be one line. It could be 6. Nothing about it is fixed. That difference has a name you already know from school. The first service is sitting a multiple choice exam. There is a fixed list of answers, and it picks one. The second is writing an essay. There is no list. It produces something new each time. This matters the moment you try to test it. For multiple choice, you write down the right answer in advance and compare. That is what a unit test is. It compares the result against an answer you already know. You can do that with the first reply. You cannot do it with the second. There is no single correct paragraph to compare against. Your code downstream has the same problem. A program can read two named fields without trouble. It cannot reliably pull a decision out of free text, so the shape of the output decides how you verify it. A fixed list of answers gets an answer key. An essay needs a rubric. Follow the first lane all the way through. It starts with facts about the transaction, the amount, the country, how old the account is, how many payments came before this one. These are called features. They are just numbers describing the event. The model turns those numbers into one more number, a score between 0 and 1. That is the whole output. Then you make a choice the model does not make for you. You pick a line. Above the line, block the payment. Below it, let it through. That line is the threshold, and it belongs to you, not the model. Watch what happens when it moves. Drag it down, and you catch more real fraud. You also block more honest customers. Drag it up, and you stop annoying honest customers. You also let more fraud through. Every position on that slider is a trade. No setting wins on both sides at once. These 4 boxes are how you read that trade. Correctly caught fraud, wrongly blocked customers, missed fraud, correctly approved payments. Those 4 boxes have a name, the confusion matrix. The model is fixed. The threshold is the dial you actually ship, and the same numbers always produce the same score. So the same transaction lands in the same box every time you run it. That property is called determinism, and it is the reason this lane is testable. Feed in a known transaction. Assert the exact score. It will not drift between runs. The answer key works here because there is an answer. Now the other lane, same request. This model does not produce a score. It produces one piece of text at a time. Those pieces are called tokens. A token is a chunk of text. Sometimes a whole word, sometimes part of one. Here is the part that surprises people. At every step, the model does not know the next token. It has a ranked list of candidates, and each one carries a probability. Then it picks one. Not always the top one. It samples from that list. That single decision is why the output changes. Run it again, and a different token gets picked early on. Every token after that one now follows a different history. A small divergence near the start becomes a different paragraph by the end. Watch the same prompt run 3 times, 3 different sequences. None of them is wrong. The model is doing exactly what it was built to do. You can turn the sampling down and always take the top candidate. Even then, providers do not guarantee identical output on every call. Treat matching output as something you are lucky to get, not something you can assert on. This is where the exam analogy breaks, and it is worth being precise. An essay marker varies because they are exercising judgment. This model varies because it is drawing from a probability distribution. There is no judgment in it. The variation is mechanical, and that is a different thing to reason about. Put them side by side on the things that decide your on-call rota. Determinism. One lane repeats itself, the other does not. Testability. One takes an answer key. The other needs a rubric, and somebody has to write it. Latency. The classifier is a single pass. It answers in one step. The generator produces tokens one after another, and each one waits for the one before it. Longer answers take longer. Latency scales with how much it writes. Cost. The classifier runs on hardware you have already provisioned. The generator is billed by how much text goes in and how much comes out. A longer answer is a bigger invoice. Now the failure modes, because they are not symmetric. The generator fails loudly and at random. It returns text that will not parse. Your code was expecting 2 named fields and got an apology instead. That failure is visible. It throws. The classifier fails quietly. The world moves on. The incoming data stops looking like the data it learned from, and accuracy decays. Nothing throws. No alert fires. The numbers still look like perfectly valid numbers. That is silent drift. One of these wakes you at 3 in the morning. The other one does not wake you at all, which is worse. So here are 8 jobs off a real backlog. Put each one in a lane. Route a support ticket to the right team. There is a fixed list of teams. That is a label. Predictive. Summarize that ticket for the engineer picking it up. The output is prose. There is no single correct summary. Generative. Detect an anomaly in payment volume. A number and a threshold. Predictive. Draft a reply to the customer. Prose again. Generative. Decide whether a document is a contract or an invoice. Fixed list. Predictive. Pull the payment terms out of that contract. This one is the interesting case. The output is text, so it looks generative. But there is a correct answer sitting in the document, which means you can check it against the source. Score a lead. Predictive. Name a new product. Generative. And there is no right answer at all. The question is never which technology is better. The question is whether your output has a fixed set of possible values. If it does, you have an answer key. If it does not, you need a rubric. Most systems that survive production use both, and the order matters. Put the cheap deterministic model at the front door. It is fast, it repeats itself, and its cost per call is a rounding error next to a generated answer. Let it handle everything that fits a fixed list. Suppose that turns out to be 9 requests in every 10. Only the remainder goes to the generator, where you pay per token and wait for tokens. Watch the counter, same traffic, a fraction of the spend. And you have contained the risk as well. The unpredictable component now runs on 1/10 of your traffic, sitting behind something you can test. So before the vendor comparison, before the model name, ask one question about the feature in front of you. Does the output have a fixed set of possible values? If it does, you are building a classifier and you can assert on it. If it does not, you are building a generator and you need a rubric, a retry path, and a budget. Pick the shape first. Pick the vendor second.